Hello everyone and welcome. On this last video, we're going to be talking about basically what I did for rendering, comping, and then the look. And then also we're going to talk about a little bit what can you do with the different attributes that we save to, tweak some properties of the particles, for example, or anything that you might be able to do with those attributes. And then also how can you utilize some of those attributes in shading as well, or rendering for comping. So let's get started. All right, so this is the graph on the post scene render graph. And as you can see, nothing super big. I just have basically what I did in this graph. I just brought all the different caches here. Like if you start from the top, we have the VDB, which is just the smoke. We have the particle detection, the skull disintegration here, and then as well as the sand or the grain simulation, right? And I'm doing a few tweaks post-sim with the attributes, and let's start from the top. So here, the only thing I'm doing is just bringing the cache, and then basically I'm just applying a material. Nothing really to it. It's very simple. If I open the Hyper Shade, I'm using the standard volume here. And I'm not using the one in Bifrost because if I open that one, so if I do standard, actually you can just right click here real quick. The only reason that I'm not using this one is because in an update, I can't remember which update it was, Arnold got this scatter diffusion option now, and it's actually a very nice option. Please read the documentation on that. But on the Bifrost side of things, we don't have this material updated yet. So that is the only reason that I use actually the one in the Hypershade. By default, by the way, if you create a new material here, so if we do Arnold, let me just type standard in the shading, and you do a standard volume, you can see by default the channels that it's reading is density, temperature, but Bifrost speed out these different attributes. So it's always look at the attributes, like voxel, fog density, and velocity, for example. We don't have temperature, but we didn't save it. But it will be voxel underscore temperature. So you need to change this in order to render with the one that comes in Arnold outside. You have a preset here. So if you say Bifrost arrow and you say replace, that's going to set up everything for you. So that's what I did. And that's it. And that's why I use the one in the Hypershade, just because of this new option right here, right? Then this is just the advection. And I have a little bit of a post-sim tweak here. And what I did basically, if we look at the data now, from here we have a few properties that we save on this cache, right? I'm grabbing the point size, which is just the size of each point, right? The particles. So if we look at this now, and basically I'm getting the normalized age, which is basically just grabbing the age and the age limit and dividing that. Remember that the age limit is just the life of the particle. And if you divide these two, basically you get a normalized age, which is just a value between 0 and 1. And when you have a value between 0 and 1, it's good for example, passing this into a ramp, which is what I'm doing here. So if you will make this bigger, and with this F curve, what I'm basically saying is that when the particle gets born, gets this size, at the middle of their life, or like half of their life, they get the full size, and then when they're about to die, they go to basically 0, right? With this kind of like nice ramp, so it's not just an abrupt going back to 0. And then I'm multiplying this by the actual point size that came with it, right? With these values, the original value. Because if you skip that, if you just override it, and then basically I'm overriding the point size. But if you don't do this multiplication, basically it's going to override these values, and it's going to go, this point is going to go huge. as you can see here, right? Because the value, remember, it's this values now. It's not the value that came with the simulation, where you're completely overriding, and that is why I'm multiplying this. And now you can see when they're getting away or smaller, they're getting smaller and smaller. I don't know if you can tell, but then if you get very close, you can see that that's what's happening. Then I'm using this the set Arnold point settings, which basically just to pick how you want to render your points, and then just applying again a shader from the hypershape. And again, it's very simple. Just grabbing the same basically texture that I used for the skull, and then just applying that, color correcting a little bit, and I did this just so I can get a little bit of a little bit of color that came from the same texture. You see that the texture has kind of like this variation, so I kind of tried to get the same variation there as well. Then here is the disintegration of the skull, and then you just get past, and we are applying this skull triplanar. And this skull triplanar is a little bit more involved, but it's really not that much. And let me again look at the data here from this. This is basically where we save, that rest attribute, right, before everything happened, and that's where we're using it right here. So if you look at this shading network here, it's very simple, just using the textures and using a bunch of triplanars. If you will look at one of this, using basically this, the coordinate space by default, I believe, is world. I think so, object, but I changed this to pref, and when you change from to pref, basically it's going to grab these two attributes, which is basically just the point position reference, and that is the name that is looking by default, and this is the normal reference, and they should be as rest. And since I saved my rest or my pref as a rest attribute, I just changed this to rest in all of them, and for the normal as well, right? And that way, and remember, I changed the coordinate space to pref because we're trying to read this from here. And that way, actually, if I didn't do that, this texture here and the skull will be jumping and going crazy all around, because first we are kind of eating away the geometry, right? Deleting the geometry, deleting the points of the geometry, and besides it's animated. And since we set up this attribute before everything, right? Before the solver that we set up back on the custom solver, before everything happened when it was completely static, this is the way that you make the textures stick. If for example, I will set up this attribute right now, right here, when it's everything animated, this will cause an issue and it will be again jumping. I don't have an example, I didn't save that, but you can test it yourself in a sphere or something like that, and you will see that effect. So that is the one use, for example, to use that rest attribute. As I said before, that is very useful. But again, it's just one use. You can use also, you can set it up, you can set it for companies, usually useful as well. There's many uses for that. And then here, we're grabbing the grains for just the part that is the hero part, right? And applying the same random rotation, right, for the points that we set up in the grain in this graph that I showed you last week, right? It's basically the same rotation on the point size. Again, point size, and then basically what I'm doing here, there were a few points that I didn't like how they were looking after the simulation, and instead of going back again to the simulation re-simming, and deleting those points or what have you, right, or anything, I can just do this post sim. And the way that I'm doing this is just basically grabbing the ID, because each point had their unique identifier, right, because we have an ID, and then I'm just saying find in this attribute these points, and I just deleted 2 points really that they were really bothering me. And this is going to start from 0 and it's going to find these points, and then I'm just feeding that into the delete node. Remember that this port by default is an auto port. It actually should be set up like this. And by default it's looking along, so that's why I fed along. And this string to array, by the way, is great because you can set up many points right here, or many strings separated with commas, like, and then just set up like that manually. And this can give you a string array, float array, or a long array. And then I'm just deleting the points. So again, another case in what we're using an attribute to do a post-syn tweaking, like what we did, for example, with the particles as well. So that's why it's so important here. Again, I saved the rest as well here. No, not in this one. I think I did here too, yeah, but I didn't use it, because it's so cheap to set up this, right? There's no point why not saving, because at the end of the day, you can be using this all over the place later on. Again, I save rest, but I didn't use it in this case for the grains. But again, point size, I can change the point size later on. Again, we have point orientation. In this case, have the point ID, which is always very important to save those, especially when you're dealing with points, like in sim, like fluids, grains, NPM, particles, any kind of point-based animation. Is very good to save an ID for each point, because then you can do stuff, for example, like this. Again, just showing you the power basically of attributes on how you can work that in that way procedurally. And then what I did, and here, like for example, why you will ask here why I didn't use a terminal and then just put all these inputs or outputs into a terminal, right? It's because I actually, as you can see here, I separate each individual output into their own node, basically. And the way that you do this, and let me just show you actually in a new graph so it makes more sense. Let me hide a few things here. And the way that you do this is, let me create mesh plane, for example. Let me create a few things, create mesh torus, create mesh sphere. And by the way, it needs to be an output. This doesn't work in a terminal because you need each output go into something. I'm gonna just leave it all in the same spot here. And let me call this, for example, I don't know, test, right? The graph is calling test. The way that you do that, just to have individual nodes for each output, is you go to edit and you say convert graph into a DG node. And the way that it's going to do that, now you can see that now each individual piece here, right, has their basically transform as well. And you can still do things to this, by the way. It doesn't mean that you cannot do anything in this stream. Like, for example, I can just do a displays points here, and add I don't know, fractal turbulence field just to display these points, for example, right? And just still that's gonna work just fine. And this is another way, if you think about it, that you can actually work with a manipulator here in Bifrost. I mean, this is fine. I still prefer to work in the shape and then just use the transform point because you have full control on that. For me, this makes more sense to do this when you are rendering, because that way give you a lot more control into your object and for your objects when you work on the render setup. Like for example, to create holdouts, or if you want to separate each individual piece in a different collection, for example, and then create an override for that, or render just that separately for whatever reason you need to, so there is a lot more control, because for example, right now at the moment, I cannot go to this. Let's say that, where I rendered here the grain, remember that I'm rendering here basically all the instances around beside the grains and then the environment. I cannot tell this graph, say, hey, I want this terminal to be in a different collection, and then I want this terminal to be in a different collection. As far as I know, you cannot do that yet. So the way that you do that is basically doing these DG nodes, and then you can control as you wish. It gives you more control overall. That's what I'm trying to say. And by the way, this test, as you can see, still this is called test, and this is actually hidden here. So if you uncheck the show DAG objects and we look for this test, it should be somewhere here. And there you go. So that's the graph, and you can convert actually this back. So if I hide this again, and let's say that whatever reason you're done with this, I can just go back to my test graph and then just say, okay, convert this graph to the shape. And then you can see that all the pieces went back to the origin, and these BIF objects, they don't do anything anymore. So you can just delete them, but you have everything there. So you have the power of the two basically things, right? You can have one shape with everything that you can treat basically as a container for everything, or you can separate each output into their own individual node. And there you go. Then I just wanted to explain that so it wasn't, so you can see the control that you can have basically on that. So then for the lighting, I'm going to touch on the lighting very quickly, but the lighting is very, very simple. It's just two lights. And if you will look at this, we have two rectangular lights. And then I have a dome light with an HDR. And then the spotlight as well, that is basically creating that fog, right, that we saw in here, right? So we see that, and you can see that there's kind of like a little bit of movement in that light as well. And the way that I did that, if I show you, if we go to an editor and I have a global here, again, it's static, there's no animation, it's just still. And then basically on the texture node, I just create a quick expression, and if we look at the expression, it's basically grabbing this, and I'm just saying, well, I want to rotate this by time. It's going to be equal to time times 4. That's all. And that is giving you that basically, just so it's not static, it's a little bit more dynamic, the lighting there. And then, this is also, this lighting is contributing to volume because we have an environment here too. So if we go to Arnold and we go to the environment, we have an atmosphere volume here. And that's it, guys. I think I cover everything. And for the Bifrost and Maya side of things, hopefully everything makes sense here. And let's talk a little bit about the comp size. Thanks. All right, welcome back. So this is Fusion. This is the beauty, and it looks dark because we need a lot to look at it correctly. So I'm using the Osio display here, and now you can look at it correctly, how it looks from your render view, basically, Arnold. It should look basically 1-to-1 if you're doing it correctly. And then I rendered a few passes like normals, P, some diffuse, direct, indirect, specular, and so on. And then I have my crypto object, which basically grabs a few mats from here, like the skull mat, so I can color correct isolated, right? I pick a few rocks here in the front, and then also a few rocks in the back. And then I just save this, pre-comp this, because it's just easy. Running this on each frame and having these crypto mats live, it can be expensive. So it's just better to write this to disk and then just use them, because at the end it's just a black and white mat. Okay, so then basically I have the spec here, which is more important. I grab the spec pass, and then I did a Luma key just to grab basically this alpha. Without that, the alpha is kind of like this, right? And I wanted to have just a little bit of more, kind of like the rocks here, and then I glow them a little bit. This X glow, by the way, and there's a few nodes that are actually here that you can grab them directly from. If you use Fusion, probably you know this about Reactor. It's a great resource where you can grab different nodes, and the community is awesome in Fusion. So I definitely recommend grabbing this Reactor here. Then I grab another mask, but this is actually the render. And you can see now I can read this very easily because it's cache and it's just sequence here. And I'm glowing that again. This rocks in the front. Then I do a color correction here. I'm not go faster here really because the comp is very, very straightforward. Just I'm using a few masks to color correct a few things and then just using some color correction LUTs and that's it. Again, I'm using the skull mat here to color correct, or another color correction here, which is just saturation a little bit. I'm using a LUT. I did a vignette here very quickly. In this challenge boolean, basically I'm just copying the C channel. Before here, if you look at here we don't have the C or the depth channel, right? So I'm using the channel boolean and I'm using the operation copy, and then I'm copying this C buffer into this. So if you look now from the channel boolean, you will see that now we have Z. And there you go. So if we try to preview this or move the gain or gamma, you can see that we have the data there. I'm using this depth of field here. I did it in comp because I have a little bit more control. This is a plugin, by the way. It's not coming from, but also Fusion chips with some depth tools that you can play with it. But it's a very cheap plugin from June. The username, and you can look it up here. So you can see with depth of field and without. And I just wanted to kind of, focus more here and not right here. So that's why I did that. Then I apply my final LUT, and then basically a little bit of film grain, and then I just using the color space and save this. And that's it. That's the comp part of things here. Then I took this into DaVinci, and I'll show you that workflow there. So this is the beauty that came from Fusion, the comp. I just played with different looks, and then I came up with a look. So if I apply the look that I have here right now, it's basically what you see in the final, is that kind of bluish world, more cold. And I just like this personally better. And that's it, really. I mean, it was just playing with different, playing with the temperature, gain offsets, and then also kind of like playing with the shadow, making it a little more bluish, giving a little bit of a curvature. And if you know how this works, you can create different nodes, for example, a corrector, and then apply whatever you do in this things here, you can apply it to a node. So then you can just disable that node if you don't like, for example, a look. So it's actually pretty powerful. DaVinci, the color edit part of the DaVinci, and it's actually a procedural as well, and at the same time. Then apply let me just go back to what it was. Yes, okay. And then lens flare and an aperture diffusion. You have different effects here that you can use, and obviously you have different notes that you can use and grab from the library. They have a bunch of different things which are great, and basically that's it. I mean, that's what I did. I mean, there is no a secret or anything. And this obviously is just a look, right? This is up to taste. And there you go, guys. I mean, this is basically the final piece. And, as I said before at the beginning of the project, this is just one option and then one version that you could present to your supervisor, client, or whatever. But, you can definitely take this further and improve for example, myself, I will definitely improve. I would like to fix a few things in the sim, in the grains more than anything, to be honest. Maybe you can have an option that the particles, there's not as much turbulence here, maybe shade the smoke a little bit differently. One thing that I would like to add, maybe just some particles here, around the environment, so it's kind of like that glittering that you play with lighting, so it's not as clean. Maybe the background can be better as well, for example. So there's a few things. But as an overall, I feel like, we explore quite a bit of what Bifrost is capable and how you can basically work procedurally in Maya on Bifrost. And also just seeing the power that attributes have, because you really have you can do quite a bit with attributes just in shading, post-sim, and you name it, because you can play, we created, remember that we started creating that custom, right? The custom solver, which is basically driving a bunch of this effect. It's driving everything, because it's driving basically the skull disintegration. Then we're driving the edge from the same spot, and we are dealing with the smoke and the particle deflection. And that is per n. It's also affecting, it's not really driving the grains, but it's affecting the grain, because since it's getting disintegrated, the grains is just falling, right? And then we also talk about a few techniques about how to just simulate what you need, with the bounce, how you preview stuff quickly, trying to move basically quickly, and then render instances where you don't need to, and then basically the environment is just kind of a static Maya thing. So with that said, I hope you learn maybe one or two things here, and you like this, and yeah, and hopefully I'll see you next time. If you have any questions, feel free to reach out, and cheers guys, until next one.